All right, if I'm given a triangle and I'm told the sides, um, and the question is find the largest angle of the triangle, the largest angle is always opposite the longest side. So looking at the three sides I'm given, I can tell the largest angle is opposite this longest side because n is positive, and this is n squared minus 1. This one here is n squared plus 1 plus another n, so it's bigger than that one. And this side over here is 2n plus 1. So if I double something, that's going to be smaller than squaring it. So here's my longest side, so this angle here must be my largest angle. Now, I don't know if it's a right angle triangle or not, so I certainly can't assume it is. So therefore I'll use cos theta. And for cos theta, we have 2n plus 1 squared, so our two sides next door squared. So that one plus that one minus the opposite side squared. So a squared plus b squared minus c squared, 2ab, or however you remember the formula, which is in your formula booklet. All right, and we need to find this angle, interestingly enough. Okay, so what am I going to do? I could probably expand everything out and simplify it. I need to expand the top and factorize, which looks a little bit annoying. Can I do it a different way? I can't see another way, except I should be able to. Oh, there's difference of two squares. I can have a look at that. So if I just go over here for a second, using those last two terms, which look difference of two squares there, I can use the first and last or the second and last. So I've used the second and last, so I've got this term take away this term, and that term plus that term, so plus I don't have to worry about the brackets. So when I simplify that, the n squares cancel, so I've got a minus n minus 1 minus 1, which is minus 2. So that would be the same as that bracket. In the second bracket, I've got 2n squareds and n. That's also, let's make it an n, 2n plus 1. All right, so then I've got, in essence, 2n plus 1 squared plus minus n plus 2 and 2n plus 1. Alright, and that's just from that working there, so let me get rid of that so I have room now. So that was just using these two terms and looking at difference of two squares just for something fun. You could expand it all out and collect together and then try and factorize if you want. But if I have a look at that, I can see that now I just have these two terms at the top, and they both have a 2n plus 1 in them. What's left, there's a 2n plus 1 minus, there's an n squared and a minus 2n. Okay, I don't think I did that the best way, but anyway, so I can cancel these two, which is nice. At the top here, I have a 2n minus a 2n, so I've got a n squared minus, so this could be, this bracket, if I put a minus outside, it could be an n squared minus 1. There we go. And that cancels with this one, so I'm left with a negative 1 at the top and a 2 at the bottom. So I've got negative a half. If I was solving in a triangle, I know that angle, so if you think about it, has to be between 0 and 180. That's all it can be. So don't forget we're looking for theta in a triangle. And this is cos theta is negative, so it must be in the second quadrant if cos theta is negative. So that's 180 minus theta. Theta being the acute angle. All right, so the acute angle would be cos of what angle equals a half, and that's 60. So 180 minus 60 is 120. So that would be our solution. Sorry, it was a bit messy.